Let's try to focus on equilibrium condition for partially submerged body. So consider one body like this shape, and some part of the body like PQRS is below the free surface. So this is here, this is the free surface, and the part which is below from the free surface, that is PQRS. So here G is the centroid of the body and B is the bound force point. So from here the bound force is acting, and from G the weight is acting in the downward direction. Now if you only focus on this PQRS, so PQRS, so here B, that is center of buoyancy, is above the center of gravity. So this is stable equilibrium. Applied moment in clockwise direction, the reaction will be anti-clockwise. So this is stable equilibrium. So now let's try to understand this concept. So this is the any type of subjective surface is there, any type of object is there, and some part PQRS is below the free surface. Okay, so PQRS is below the free surface, and here the centroid of the body G is above the center of buoyancy. So here in that case B is above G, and here G is above B. So from here bound force is acting upward direction, and from here the weight is acting from the downward direction. Okay, now if you take a applied couple, if you keep applied couple in clockwise direction, so what is happen? So this is the free surface here, and you apply some couple in this direction. Okay, so the new position is that P dash, Q dash, R dash, S dash, and G is acting from this direction and B is there. So what will happen? This B point is converted to B dash, and from this point the buoyancy force will act. So here you applied the clockwise couple, and between these two force W and FB, they produce a moment anti-clockwise. So here this is a applied force, that is a clockwise moment, there is a clockwise moment, and here this is anti-clockwise moment is there. So that's why the body will come back to the vertical position again. So this is the stable equilibrium. So theta is the angle of the body. Okay, so what is happen? So W is the downward direction and AB is the upward direction. So what will happen? This will create a anti-clockwise moment. So you apply the couple in clockwise moment. So this will create anti-clockwise moment. So this is the stable equilibrium here. So here remember that this B point is converted to B dash. So when B dash, the buoyancy force, is meet the centroidal axis, then this point is known as metacentric point. Okay, remember this data. Now let's try to understand what is the concept, what is written in this book. For partially submerged body, the center of buoyancy is below than center of gravity, and this body is stable or unstable. So the new concept is used to define the stability or instability, that is metacentric point. The metacenter is the point of intersection of new line of action of buoyant force and centroidal axis. This distance between metacenter M and center of gravity G is known as metacentric height GM. If M above G, then the body is in stable equilibrium. The metacentric height is used to define the stability and instability of floating body. So this is the concept of the equilibrium condition for partially submerged body. Very, very important. Now, so here suppose this is the B, center of buoyancy. So this is the centroidal axis here. So when you apply some couple, so focus on this this body. Okay, so G is above B. So in that case, if G, that is centroid of the body, is above the above the center of buoyancy. So what happened when you applied couple in that direction, clockwise direction, then B point is coming to the B1 point. So consider this is B1 point, and perpendicular to this, here it will meet at point B, point M. So this is the M is the metacenter. Okay, so this is clockwise and this will generate anti-clockwise. So this is a stable equilibrium, positive restoring couple. So it is stable equilibrium. So here GM is the metacentric height. Okay, G to M is the metacentric height. So now if you focus on here in that in that case, so what happened here, G is above M. If G is above M, what will happen if you apply some couple here? So G is above B. So G is above B. In that case, what will happen? What will happen? G is downward direction and buoyancy force which is upward direction, and here there is a clockwise movement. So here the clockwise couple, and here also there is a clockwise couple. So the body cannot reach to the original condition or vertical condition again. So that's why it is a negative restoring couple or unbalanced equilibrium. So it is known as unbalanced equilibrium. So here B point is converted to it transferred to B1, and here this is the metacentric point. M is the metacentric point, or you can say metacenter. Okay, so negative restoring couple, that's why it is an unbalanced equilibrium. So what is B? B is the center of buoyancy or centroid of the body. G is the center of gravity. M is the metacenter. So now if you want to calculate what is the distance M and X, so consider this point is X, and if this angle is theta, so here this is the tilted axis and this is the vertical axis. So here if this angle is theta, so this angle will be theta. So if this is the angle theta, so what is the value of mx? So right arm mx, that is equal to gm sin theta. So here this is gm and this xm, this distance is the gm sin theta. Now if you want to calculate the restoring couple, that is equal to this force. So W is downward direction, this force into perpendicular distance, that means multiplied by m in mx, this distance. So how to calculate restoring couple? So W into this distance. So W into perpendicular distance, gm sin theta. So if the sin theta is very small, then sin theta is equal to theta, or this is almost equal to tan theta. So the restoring couple will be WGM tan theta. So this is very important. Remember this data. This is my handwritten notes. The PDF link is available on the description. You can download it and read by your own. Like, share, subscribe my YouTube channel. Thank you.